All right, and this next one, at an automobile factory, there's 1,849 parts are made in 4 hours. What is the average rate at which parts are made? And remember, rate is just a special kind of ratio. So as we talk about ratios, this is talking about parts made per hour. That's telling us how to set up this ratio. Parts per hour means parts over hours. And so when we do this, we just say, hey, you know what? This is going to be 1849 over the 4. And now that is a ratio of parts per hour, but it asks for the rate here. And typically when we do the rate, we'll actually do the division here. All right. So we could say the rate is, 1,849 per 4 hours, but that's kind of a weird way to think of it. If we actually do the division here, we get 462.25. And again, that's parts per hour. Okay. And so remember, rates are just special ratios where the units are different. And usually when we have the units that are different, we'll actually do the division. Just like if we were doing like miles per hour or something like that. This is parts per hour. Okay? Sorry, I put per there instead of hours. There we go. Okay? If I look at the next one, it says the total cost to rent a rowboat is $16. Times the number of hours the boat is used. How long can you rent the boat for? $224. And so there's a couple ways that you can do this. You could kind of take it at face value and say, okay, it's 16 times the number of hours, which I'll call T, and I want to know when that's going to equal 224. And then you could solve this one and do the divide each side by the 16. Let me write that. So we end up with T equals 14. And again, that's hours. But you could also think of it in terms of ratios and proportions. You could say, hey, you know what? $16 goes to 1 hour. So now $224 goes to how many hours? Okay. And whenever we're setting up a proportion, we just got to make sure that we set up each fraction in the same way. Okay. If one is dollars over hour, the other one better also be dollars per hour. Okay. And so then if we cross multiplied here, we get 224 equals the 16t. And of course, we've already done this. The result is going to be the same. Okay? But just thinking about that from the perspective of ratios and proportions. Okay? If we look at this guy, car A travels 180 miles in 7 hours. Car B travels 350 miles in 4 hours. Car C travels 584 miles in 15 hours. Which car has the fastest average speed? And so if we look at this, we can set up a ratio that shows us the speed. Speed is miles per hour, so miles over hours. But as we kind of compare these, if I look at this first one, 180 over 7, the next one, 350 over 4, and the last one, 584 over 15. I want to know which of these is the fastest. Well, it's hard to compare these when we leave them the way they are, all right? And this kind of goes back to this other question, number 29. Whenever we have a rate, typically we'll do the division because it's a nicer way to look at it. It's an easier version of this thing to kind of think about. And so I'm going to do the same thing with these guys. Comparing them where they are is tough. But if I actually do the division here, this one, I get a 25.71. And again, that's miles per hour. If I look at the next one, the 350 divided by 4, that's an 87.5. Again, that's miles per hour. And then the last one, the 584 divided by the 15, gives me a 38.93. And again, that's miles per hour. Okay, and so even these might have been a little bit tough to compare the way they were written, all right? By writing them in terms of these decimals in that miles per hour format, these are really easy to compare now, and it's really easy to look at that middle one and say, oh, that's clearly the fastest. So it's car B. Okay? And we can even see the slowest there as well. All right, those are probably a tougher comparison to make. Okay. If we look at these, just solving proportions. Remember, we solve proportions by cross multiplying, and proportions are just when we have two fractions that are equal to each other, two ratios that are equal to each other. So we cross multiply. So on this one, I take the negative 5n times the 2, and that gives me a negative 10n. And then I take the 15 times the 4, and that gives me a 60. And remember, we set those things equal to one another. The most common mistake that students make here is we cross multiply, we get the negative 10n, and we get the 60, but we don't know what to do with those two values. We set them equal to each other. Make sure you set those equal to each other. And now we solve the equation that's left. So this one, I'm going to divide each side by the negative 10. So I get n equals a negative 6. That's it. If I look at the next one, same kind of thing. I'm going to cross multiply. So here I'm going to do the negative 4a minus 1 times the 8. And keep in mind, when I multiply those, that's my distributive property. If I have a binomial, if I have a big thing like the negative 4a minus 1, and I multiply by something else, I have to distribute that multiplication. And if you need to write that step and say, you know what, I need to do 8 times this whole thing, okay? It's that entire value, that entire numerator, that entire negative 4a minus 1 times the 8. And then here I got to multiply these guys. I'm going to say equals. Remember, we set these things equal. The 3 times the negative 10a is going to be a negative 30a. And now I'll do my distributive property. Okay? And you can absolutely do the distributive property as you go here. I could have cut out that first step. Sorry, that's messed up my sign here. And now I can continue to solve from here. So here I'm going to add this 32a to each side. Remember, whenever you're solving equations that have variables on both sides, try to take care of the variables first. Get those on the same side before you do anything else. And now we divide. And that's it. Okay? Cross multiply. Make sure you do your distributive property where appropriate, and then solve for what's left. Okay. The next one, same kind of thing. Maybe I'll do the distributive property in my head this time. It's w plus 14 times the 4, so I have to distribute that 4. That's going to be a 4w plus 56. And then equals, remember I set these equal to each other. Once again, I'm going to multiply the 3 times the 4w plus 6. I once again have to do my distributive property here. So that's going to be a 12w plus 18. That is a terrible looking 18. Let me try again. And now, once again, I'm going to solve this the same way I always do. I'm going to take care of the variables first. So I'm going to subtract that 4w from each side. And now I'm going to subtract the 18. Looks like I got 38. And now I've got to divide. And for your answer on this one, we could leave it like this as 38 over 8, and that's okay, but we just have to reduce that. That would be a 19 over 4. So you could leave it as that fraction, 19 over 4. If you want to write that as a mixed number, that would be okay. Let's see, that goes in 4 times with 3 left over, so 4 3/4. Or I guess you could write it as a decimal 4.75, all right? So lots of ways to kind of express this answer. Any one of those is fine, okay? But again, we cross multiply. When you cross multiply, you set those equal to each other. You solve what's left. In this one, a tree casts a shadow that's 10 feet long. A 5-foot-tall boy standing next to the tree casts a shadow that's 2.5 feet long. If the ratio of the heights and the shadow lengths are proportional, how tall is the tree? And so as we're looking at this, we're just going to set up a ratio for each of these. And since they're proportional, it means those ratios are going to be equal. All right. So it tells us right here that this kid is 5 feet tall. And so if I set up a ratio between his height and the shadow, the ratio would be this. It would be 5 feet in real height is equivalent to 2.5 feet in shadow length, okay? That's the ratio of height to shadow length for the kid, all right? And if it's proportional to the tree, it means it equals that same ratio set up for the tree. And so once again, I don't know how tall the tree is. I'm going to call it X. But if I set up that first ratio as actual height to shadow length, well, this one's going to be actual height to shadow length. The actual height of the tree is the thing I don't know. It's X. The shadow length of the tree is 10. And so once again, when you're setting up proportions, in these word problems, it's just important to make sure that each fraction matches in terms of the structure. If the first one was actual height over shadow, the next one has to be actual height over shadow. And now I can cross multiply. Again, x times the, so x times 2.5 is 2.5x. 5 times 10 is a 50, and I set those equal to one another. Okay, and so now I just solve what's left. Okay, so I'm going to divide each side here. So we get x equals 20. And again, that's the height of the tree, so it's 20 feet. Okay, but again, the key here is making sure you set up each fraction in the same structure. If I look at something like this guy, what percent of 100 is 78? And so if I had 78 out of 100, well, I should understand that percents are literally values out of 100. So if I have 78 out of 100, that translates to 78%. Okay, and if we kind of take that through the decimal version, it's 0.78. We can just move the decimal a couple places. Okay. For the next one, it says 125% of what number is 246 or 264. And so again, whenever we're dealing with percentages in an equation type of format, we just write them as decimals. So this guy is a decimal, would be 1.25. And when I find the percentage of something, I just take the decimal version of the percent times that thing, and it should give me the percentage of that value. And so as we look at this thing, it says 125% of what value, so times what will give me a 264. And now I can solve this thing. Okay, so once again, I'm going to divide each side. And you could also do your is over of equals percent over 100 on this if you would like. That's an acceptable way to do it. So it's 211.2. Okay, so if I found 125% of 211.2, it would give me 264. Okay. If I look at this one, Laura's buying a new table for her dining room. She finds one that she likes, and she estimates that the tabletop measures 7 foot by 4 foot. The tabletop is actually 8 feet by 5 feet. What is the percent of error in the estimated area of the tabletop? And so basically we're just asking, hey, by what percentage was she off in terms of the areas? And so if I look at the area of the what she estimated, so her estimated area was 7 by 4, so it's 28 square feet. We just multiply those. Okay, that's how we find the area of a triangle. The actual area was 8 feet by 5 feet, so if I multiply those, that's 40 square feet. And so if we want to know, hey, how far off was she? Well, we got to look at the difference between this. If I look at the difference between 40 and the 28, she was off by 12 square feet if I subtract those, okay? So I do the 40 minus 28 because I want to know how far off she was. She was off by 12 square feet, okay? So that's her error. Her error is 12 square feet. That's how far off she is. But if we want to look at that in terms of a percentage, okay, we want to compare that to the actual. I would say, hey, 12 over 40, well, what percent is that? And really, that's just a job for my calculator. I divide it, and I get 0.3, which translates into 30%. So her estimate was 30% off. It was off by 12 square feet. 12 square feet is 30% of what it's supposed to be, okay? If I look at this one, Glenn is looking into buying a piece of land. He estimates that the land measures 100 yards by 850 yards. The actual is 140 by 940. What's the percent of error? So once again, we're calculating how far off he was. So if I find the estimated area, and once again, this is a job for my calculator. I plug it in, the 100 times the 850. Well, this one you probably don't need to plug in. Gives me this. Again, that's square yards. The actual area, and this one you might actually have to plug in. You probably don't want to do that one in your head. The 140 times the 940 gives me 131,600. And so again, we see his estimate. We see the actual value. I want to know how far off he is. So I'm going to just subtract these to see how far off he was. Okay, how many square yards was he off by? And so I subtract this. And I get 46,600. So that's how far off he was. He was off by 46,500. But what is that as a percent? If I want that as a percent, I need to compare that to the actual area. Okay? And once again, my calculator does the work for me on this. And I get 0.3541, something like that, which translates into 35.41%. Okay? So again, I'm looking at his estimate, I'm looking at the actual, I'm seeing how far off he is, and then I'm converting how far off he was into a percent. That's it. If I look at these guys, just solving these, I solve these the same way I would solve equations. The only difference is when you're solving inequalities, if you multiply or divide by a negative on each side, you have to flip the inequality sign. So if I look at something like this guy, to solve this, I would divide each side by a -8. And since I divide each side by -8, I have to flip that inequality sign, so that's a greater than symbol now. And now 48 divided by the -8 is a -6. Okay? If I were to graph this thing, once again, I would use an open dot, and I would shade everything that's above this guy, okay? And if you're an above the line person, that's fine as well, okay? But just remember how we graph these things as well. If I look at something like this guy, there's a couple ways that I could do this. I think most students would probably do this. They would probably distribute that 3. And now to finish solving this thing, I'm going to subtract the 6 from each side. And then divide each side. And since, once again, I divided by a negative here, I have to flip the inequality sign. And now if I wanted to draw a quick sketch of this thing, this one would be an open dot, and then shaded everything that's below that value. And again, when we're looking at the answer, the actual answer is these inequalities, okay? The graph is just a little bit extra that we have to do. We use that to check certain values eventually, okay? If I look at the next one, once again, distribute the 2, simplify and then solve the same way we would solve an equation. I have to get the variables on the same side, just like I do with equations, so I'm going to subtract the 2x from each side. And then I divide. Sorry, I've changed that to an equal sign like a crazy person. There we go. And so this one, we don't flip the inequality sign because we didn't multiply or divide by a negative, even though there is a negative value. We didn't apply that negative value. So the sign stays the same. And once again, if I were to look at the graph of this thing, it's a closed dot this time because of the equal to condition, and then I shade everything that's less than that value. Okay? If I look at the next one, once again, use my distributive property, solving these the same way I would normally solve equations. I combine like terms because those x's are already on the same side of the equation. And now I can solve. Subtract the 6 from each side. Divide by the 4. And once again, at no point did I multiply or divide by a negative, so I don't have to flip this inequality sign. Okay? And I'm going to forego the graph this time. It's going to be an open dot, and I would shade everything to the left, okay, because I want to be less than that value. If I look at the next one, once again, I'm going to solve, so I'm going to subtract the 16 from each side. That's going to give me a 21. I divide each side by the -7. So now I divided by a -7, so I have to flip the inequality sign, so that's less than or equal to. That's going to be a -3. And once again, that's my answer. The graph of this thing would be a closed dot and shade everything to the left. Okay? If I look at the next one, this thing looks like a mess, all right? It looks ugly, it looks messy because of all the fractions that are involved here, okay? And remember, just like equations, I can always get rid of all of the fractions by multiplying through by the common denominator. And so as I look at this one, they're all denominators of 2, which means I can get rid of all of these fractions if I just multiply everything by 2. Okay, so I'm going to distribute that 2 to everything on each of these sides. So here that's going to be a 3x minus 6. Over on this other side, it's going to be a 2x plus 5 minus x. And it really simplifies this thing a lot when we get rid of those fractions. So multiply through the common denominator, multiply everything by that common denominator, get rid of the fractions, and now we can solve this one the same way we'd normally solve it. Okay, I start combining like terms over here. That's going to be an x plus 5. Now I have to get the x's on the same side. I'm going to subtract the x from each side. I'm going to add that 6. And then divide by the 2. And again, I did not multiply or divide by a negative at any point. I can leave this as just 11 over 2, or you could write it as 5.5 or something like that. But that's my answer. Okay, and that one, in terms of the graph, will be an open dot, shaded everything to the left. Okay. If I look at the next one, a compound inequality is just like solving 2 inequalities at the same time. And so I look at the middle. I look at the middle where x is, and I say, okay, if I had a 2x minus 7, how would I solve for x? Well, I would add 7 to each side, and then I would divide by 2. And so I do that. I add 7. But I just have to do it to each of these outer pieces as well. I have to do it to all 3 of these sections, okay? And now the next thing I would do to solve for x, again, if I focus on the middle, is divide by 2, but I just have to do it to all 3 pieces. And once again, the graph of this thing, this one I will throw a quick sketch of the graph up. It looks like on the 2 side, I have an equal to condition, so that would be a closed dot for the 2. On the 8 side, I have an open dot because there's no equal to condition. But then if I want to be bigger than the 2, and that's what this says, you got to read it from the middle. It says greater than or equal to the 2, but at the same time less than the 8. Well, values that are bigger than 2 but less than 8 are all the values in between 2 and 8. And so I shade in the middle. Okay? And so once again, this is my answer. All right, but the graph is going to be useful in certain situations as well. All right, an OR inequality is even easier. An OR inequality is just literally 2 separate inequalities. So I just solve each of them as if I'm solving 2 completely separate inequalities. All right, so here I'm going to subtract that 5 from each side. And then divide by the 3. And I could leave it as 14 over 3. I'm actually going to write it as a mixed number because I know I'm about to graph this thing in a little bit. So that goes in there 4 times with 2 left over, so 4 2/3. Over here, I do the same thing. I just solve. Divide by the -2. And again, the same rule applies. Since I divided by a negative here, I have to flip the inequality sign. And I put that OR back in between, okay? And when we graph an OR inequality, we're not looking for what the 2 pieces have in common. It's not a restriction on both. We just graph each of these individually, okay? Oh, that's a terrible scale. I don't know what I'm doing here. There we go. And so just kind of getting a feel for where these pieces are. Less than a -5 would be an open dot and shaded to the left. Greater than a 4 2/3 would be an open dot. Oh, sorry, that one I dropped the equal to condition. That one's actually going to be a closed dot. And then shaded everything above that value. Okay? So again, this is my answer. And then we can see how that translates into the graph. Okay? If I look at the next one, another compound inequality here. Once again, I can get rid of these fractions that I see all over the place by multiplying through by the common denominator. So if I look, the denominator here is a 2, a 3, and a 6. The common denominator is a 6. So I'm going to multiply this middle section by 6, but I have to do the same thing to each of those outer sections. So I just multiply everything by 6. I start distributing. Over here, that's going to give me a negative 9. In here, as I distribute that thing, that's going to give me an 8x minus 18. And over here, I get a 5. And now I do the same thing that I've done previously. I do the same thing to all three sections. I add the 18. And again, that middle section kind of guides me as to what to do to solve for x. Over here, that's a 1 and 1/8. Over here, that's a 2 and 7/8. And now once again, I could graph this thing. And so as I look at this guy, I've got an equal to condition on the 2 and 7/8 side, so that's a closed dot over here. An open dot for the 1 and 1/8, and then I want to be bigger than the 1 and 1/8, but smaller than the 2 and 7/8, so I'm shading in between. Okay? For this guy, remember absolute value, we always have to split up. So an absolute value equation, we split into two equations because the absolute value is the distance from 0. And so if the distance is 13, there are two numbers that are 13 values away from 0. So the 2x plus 5 could equal a 13 because that's 13 units away. But the 2x plus 5 could also equal a negative 13. Okay? Remember, negative 13 is also 13 units away on the number line. And now I solve each of these. And then I divide by 2. Again, it's just two equations to solve. It's just knowing that initial setup that's important, okay? And then I can always plug these back in, plug them back in, make sure they work. Each of these does work when I plug it back in, okay? If I look at the next one, I'm not ready to split this up yet because I don't have the absolute value equal something. I need to get the absolute value by itself first, okay? And so here I subtract the 7 from each side. And from here, I could split this up. If I did, I would get 4x minus 3 equals a negative 3, and a 4x minus 3 equals a positive 3, and I would solve each. I'm going to kind of abbreviate this for a second. Here I would add the 3 and then divide by the 4 and get x equals a 0. Over here, I would add the 3 and divide by the 4 and get a 6/4, which is a 3/2. But then if you plug each of these back in, neither one works. This answer doesn't work. This answer doesn't work. And so the answer is no solution. And the reason I kind of breezed through the rest of this is we should recognize that in this step right here. Okay? At this step, when we see absolute value equals a negative, we should know that that is impossible. Okay? The absolute value measures a distance, so the absolute value will never actually equal a negative. So anytime we see that, we can immediately say no solution. If we continue to solve this thing, we'll get two answers that don't work. So make sure you plug your answers back in to check them, okay? If I look at the next one, again, we got to isolate the absolute value first. So I'm going to subtract the 5 from each side. And now to get rid of that 1/3, remember a 1/3 is just a divided by 3, so I multiply by 3. And now I have the absolute value by itself. Now I can split it up. X minus 2 equals the 6, or x minus 2 equals the negative 6, and I can solve each of these. So it looks like x equals an 8 and x equals a negative 4. Plug them back in, make sure they work. These do. Okay? For absolute value inequalities, we do the same thing, but when we do the negative version, we have to flip that inequality sign. So for this one, the two inequalities that I set up are x plus 4 is less than 12, and then I still do the x plus 4 and I do a negative 12, but I just have to flip the inequality sign, so I do a greater than symbol for that one, okay? And the idea here is that we're constructing a compound inequality, either an and or an or, and we can tell that by looking at this symbol right here. If the absolute value is less than, it's an and. If the absolute value is greater than, it's an or. So this one's going to be an and inequality. Okay, so don't forget to put that word and in between. It becomes very important. We have to distinguish between the and the or. And now I just solve each of these. I have two inequalities to solve, so I solve them. And I end up with this. I end up with x is less than an 8 and x is greater than a negative 16. And we could leave it like that. That would be an acceptable answer. I'm going to rewrite it like this. Negative 16 less than x less than 8. It's a nice succinct way of writing it. It means the same thing. If you look at it from the middle, x is bigger than the negative 16 but less than the 8. Okay? If I look at the next one, same kind of thing. I have to isolate the absolute value first. So let's get this absolute value by itself. And then we can proceed like we did in the previous example. Okay. Now that the absolute value is by itself, I can go ahead and split this up. So I've got 4b minus 2 is less than or equal to 14. I've also got 4b minus 2 is greater than or equal to the negative 14. And because the absolute value is less than this time, it's going to be an and. And now I solve each. And I'm kind of solving these simultaneously because it's the same steps. So I like to write the plus 2 all over the place first and then go back. And now divide each side by the 4. So I end up with b is less than or equal to the 4 and b is greater than or equal to the negative 3. Okay? And I can leave it like that, or I can rewrite it this way. Negative 3 is less than or equal to b, less than or equal to 4. They mean the same thing. The second version is the one that's more widely seen and more widely accepted. Okay? If I look at the next one, it might look at first glance like this thing's going to be a no solution or something like that, but make sure you get the absolute value by itself before you make that judgment call. So here, divide each side by the negative 2 first. And once again, when you divide by a negative, this is still an inequality. You have to flip that inequality sign. So now it's greater than a 4. Okay? And so now I do have a positive over there. Now I can split this thing up. 2w plus 4 is greater than the 4. 2w plus 4 is less than the negative 4. Okay? And now I solve each. And this one's going to be an or this time because I have to look at the step where the absolute value is by itself. I'm looking at this step for that determination. The absolute value is greater than, so it's an or this time. Okay? And now I solve each. And divide. So I've got w is greater than 0 or w is less than a negative 4. And you cannot rewrite this as one kind of string of characters like we can with the and. You have to leave it separated with that word or in between. Okay?